So we're going to start off fairly plug and chuggish, and then we're going to get more conceptual. Number one, how much momentum? This is really quizzing or testing. Do you understand the definition of momentum? We said that momentum was equal to mass times velocity. Mass is 80 kilograms. Velocity is 22, which ends up being, I think, 1,760, yes? Kilogram meters per second, 1 mark. Now, technically, I should have said in this question, what's the magnitude of the momentum? Because momentum is a vector, but I didn't give you any directions, so let's assume if they don't give me any directions in the question, they don't want any directions in the answer. Question number 2. A motorbike has a mass of 220 kilograms. A constant force acts on it for 58 seconds. The bike's initial velocity is 23. Its final velocity is 52. What change in momentum does it undergo? Chris, what's another word for change in momentum? I think it is. So I could give you this same question on your test, but instead of saying change in momentum, what could I ask you to find? There's 2 ways to find the impulse or the change in momentum. One way is to realize that you could calculate it with that. The other way is to realize that you could calculate it by going change in anything, which is final minus initial. Which one do you use? Depends on what they give you. So when I look in this question, I notice they gave me a final and they gave me an initial. They did give me a time, so initially I thought maybe they wanted me to go force times time, but they didn't give me a force, and I was clever. I read part B and said, oh, they want me to find the force there. I'll bet you I'll use part A to find part B. I've done enough of these. So I said the impulse, the change in momentum, is going to be the final momentum minus the initial momentum, is going to be mass times the final velocity minus mass times the initial velocity. 220 times 52 minus 220 times 23. 6,380 units, kilogram, sorry? Kilogram meters per second, or Newton seconds. Newton times seconds, usually how I write it. What's the magnitude of the force? Well, now I can use this, but I can get the force by itself. I think the force is going to be the change in momentum divided by the time in seconds. It's going to be 6,380 divided by 58. It's going to be 6,380 divided by 58. 110. 110 what? Newtons. It's force. 1 mark. Again, half mark off if you botch the units. Generally how I mark these on a test as well. Water skiing. Oh, that'd be nice. An 80 kilogram water skier moving at 18 meters per second lets go of a tow line. I visualize it. Oh yeah, he would slowly skip to a stop along the water and then sink. I've seen that before. What impulse is needed to bring him to a rest? What's another word for impulse? So they want me to find this. And as I look, I notice they didn't give me a force. They did give me a velocity. So I think I'm going to go momentum final minus momentum initial. Why can I say that the final momentum is 0? Rest, oh, comes to a stop. Minus, the initial momentum is going to be mass times velocity. It's going to be negative 80 times 18, 1440, I think. Kilogram meters per second. Now I'm going to be fussy. If you don't have the negative, I will take a half mark off, because when it asks what impulse, he needs to lose 1,440 kilogram meters per second before he can come to a stop. B, if the impulse is provided by the water, which exerts an average force of 270 newtons on the skier, for how long should this force act? Ah, now they're asking me to find time. I think time ends up being the impulse divided by the force. It's going to be negative 1,440 divided by 270. Now, if I do that, Race, can you see I'm going to get a negative time? And I'm sorry, Einstein suggests that we can't have negative time. technically the force is in the opposite direction of motion. You could call that negative. Although, Jordan, if you just wrote your answer as positive time, because you said, I know the answer is positive, and you were sloppy with your signs here, I wouldn't freak out. I would not take marks off in this particular case. So it's going to be this divided by 27, and we get 53.3 seconds. That's not right.
5.3.
That was seeming way too big. I've seen people scooch when they let go of their tow line. They don't continue going on the water for almost an entire minute. How about 5.33 seconds, and let's nuke that decimal right there. That seems about right. 1, 2, 3, 4, 5. Yeah, I've seen people going fairly fast that were able to slowly coast to a stop on the water in 3 or 4 or 5 seconds. Even that seems a little bit high, but reasonable. Turn the page. Now we get to the 2 markers. This is a collision. This is a job, Matt, for what? Disagree with change in momentum. Another C word. Conservation of momentum. In fact, Matt, generally we started like this. Now, if you didn't start out by writing this, I don't take marks off. I just like to always give a standard approach whenever possible. And in Physics 12, when we start colliding at angles and we move from equations to actually adding pictures together, it's nice to start off with something fairly reassuring before we get into the complicated stuff. So I tend to use this approach in Physics 12 too. Let's keep going. Before the collision, Matt, what's moving? Mass 1, Mass 2, or both?
Both.
Stuck together or separate?
Separate.
So if you jumped straight to this line and you said momentum of the first guy plus momentum of the second guy, I'm totally good with that. Wham! They collide. After the collision, what's moving? Mass 1, Mass 2, or both?
Both.
Stuck together or separate?
Separate.
Yep.
Together.
Oh, which one? Why would together be a silly question in this case? If they were stuck together and I said find the velocity, why would that be a silly question to ask?
Just gives you the velocity of one of
I gave you the velocity of the other one. If they're stuck together, aren't their velocities the same? You wouldn't have to do any physics. Final velocity would be 0.34 meters per second in the same direction if they're stuck together. So, ready? Scene 1, Act 1, and take 2. After the collision, stuck together or separate?
Separate.
Well played, I say to you, young man. Well played. So it's going to be momentum 1, final, and momentum 2, final. Well, momentum is mass times velocity, so it's going to be m1 v1 initial, m2 v2 initial, m1 v1 final, m2 v2 final. All right, now for the trickier part, Matt. What are they asking me to find in this question? I'll give you a hint. It's a velocity. Are they asking me to find V1 or V2 and final or initial? What do you think, folks? V1 final? Velocity of the first guy after the collision? So, I want to get that by itself. How? And by the way, this is complicated enough that if you decided to just start plugging in numbers right here, Enzo, I'm okay with that. But I think I can get this by itself. Any suggestions? First, I need to move that. And what's in front of it? A plus sign. So how will I move it over? Divide. Divide. Subtract. Divide. Good gosh, do it. So if I hear you correctly, and I think I do, you're saying that V1 final is going to start out as M1 V1 initial plus M2 V2 initial minus M2 V2 final. I totally agree with that. I think that takes care of moving that term over. Now I got to deal with that term. What's it doing to the V, Abe? What's the M1 doing to that V? Adding, subtracting, multiplying, or dividing? Multiplying, so how will I move it over? I think I will. By the whole thing, yoink, like that. And now it's plug and chug. Chris, complicated plug and chug. Yes, I agree, but plug and chug. It's going to be it's going to be, come on, pen. Oh, it's been doing so well up until now. It's been working so well up until now. Okay, let's try doing this, Mr. Do It, temporarily. Okay, we're back. Not really. V1 final is going to be mass 1, 0.25. V1, oh, I scrolled down a little too far, 0.35. By writing that, Matt, I've just decided that that way is positive. Plus mass 2, 0.15. V2, 0.2, positive or negative? Oh, it says in the same direction. So 0.2 minus mass 2, which was 0.15. V2 final, 0.34, positive or negative? Same direction. All divided by mass 1. What'd you get? Is it 0.266 if I recall? Yeah. I agree. Units? Meters per second. In terms of marking this, if you got the right answer, Greg, you get 2 out of 2. Otherwise, I would probably do something like this. I think I would give you a half mark if I saw that line right there. I think I would give you a half mark if I saw that line right there, a half mark if I saw that line right there, and then a half mark for the answer. By the way, this line is pointing to this thing. 2 out of 2. How else can I ask this question on a test? What if I'd had something rebound and bouncing in the opposite direction? What's the only change you'd have to make? Some of your velocities would be what? Negative. Okay, that's fair game as far as I'm concerned. Stuck together, that's fair game as far as I'm concerned. Coming in at separate velocities, one positive, one negative in different directions, that's fair game as far as I'm concerned. So the message here is, Maddie, be careful with direction, direction, direction. Let's shoot something. A bullet of mass 0.065 strikes a wooden block of mass 5.5. The bullet becomes embedded in the block. That sounds like a collision. I think I can say the sum of all the momentum before the collision equals the sum of all the momentum after the collision. Or this is a job for conservation of momentum. Brad, before the collision, what's moving? Mass 1, mass 2, or both? Mass 1. So it's going to be momentum 1 initial. Wham, they collide. After the collision, what's moving? Mass 1, mass 2, or both, my friend? Stuck together or separate? Stuck together, and you may manage to keep your mind focused while dropping your pencil a couple of times. That's multitasking. There you go. Momentum of both. Final. Momentum is going to be mass 1 V1 initial. That's momentum 1 initial. And this is going to be mass 1 plus mass 2 V final. What are they asking me to find? Oh, here's a twist. They're asking me to find the incoming, the original velocity. Okay. TJ, they're asking me to find V initial. How would I get V initial by itself? What would I do with this M? What's this M doing to the letter V? Adding, subtracting? So how will I move it over, oh pray tell? I think you would. By the way, isn't this better than the stupid triangle thing that they teach you in grade 9 or 10? You wrap your brain around it, trickier, but hey, it works for any equation on the planet. And if the equations get tougher, I don't think the rewriting gets that much tougher. You just got to keep track of a few more things. Hopefully I've sold you on it. Anyways, V initial is going to be the mass of both of them added together, V final, divided by, or we can go with our standard of reference. Even TJ can, yeah, okay. You brought that one up earlier, right? TJ, my friend, what's mass 1? I couldn't possibly care less about your self-esteem. What's mass 1? Read, my friend. Figure it out. I know. That's okay. Figure it out. What's mass 1? What's the first mass?
It would be 0.065.
I totally agree. Did I miss it? No, that's good. Plus, what's mass 2? Yep.
5, 25.
Language, sir. What's V final after the collision?
Still me?
Yeah.
Holy I don't know, it'd be like 11.
I totally agree.
Right.
All divided by, what was mass 1 again, kiddo? Still you.
0.065.
Got a calculator?
Nope.
Greg, can you loan TJ your calculator, please?
Yeah.
Greg, got a calculator?
Yeah, what's it?
Got a calculator, Greg? Maddie, would you be so kind as to loan my friend TJ, Maddie, Cliff, have you got a calculator back there? Could you loan TJ your calculator, please? This is for a reason. I'm not trying to make fun of you. I'm doing this. You'll see in a second. It's a bonus, but it's not the purpose.
I'm doing that thing up there, right?
Yep. So bracket 0.065 plus 5.5, close bracket, times 11.
I can read.
Thought you said you couldn't read. Look at him, now getting cocky. I like it.
I messed up though.
Try again. What'd you get?
I got 9.
It's big. It's like over 900, I think. Yes?
Well, you asked me and then you interrupted.
Sorry. I wanted to let, so that if you were uncertain, I was trying to let you know. What'd you get?
941.769.
So 942? It's a velocity. Units?
Oh, that would be kilograms and then meters per second.
That would be for momentum. This is just a velocity.
Oh, then I don't know.
Yeah, you do. You just don't know that you know.
Meters per second?
Yep. Do me a favor. On your quiz, give yourself 1 out of 2 on this question, because I know you didn't do the question, but give yourself 1 mark, please. Rest of you, that's why I was doing it. I figured I'd give you some marks, right? Same as before. If you get the right answer, 2 out of 2. Otherwise, I would probably go something like this. I would probably say half mark if I saw that. Half mark if I saw that. Half mark for that. And a half mark for the answer. Can you give yourself a lovely score out of, count 'em, 9, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8. 9. 3 squared. Square root of 81. Cube root of 729. I just gave you 2 unit reviews. These are both officially due the day of the test, Thursday. You can hand them in sooner than that if you want to. The only worry I have is if you need them to study from, I might not be able to get them back to you beforehand. I might. I'm going to try and get it done this weekend if I can. You have 2 reviews. The first one was a conceptual review, and it looked like this one here. The answers are attached. This one, very little math, mostly just trying to wrap your brain around this idea, Matt, of conservation of momentum and of impulse and change in momentum. So that one you can complete. My students' last block finished it in about 10 or 15 minutes. It didn't take that long. Then there's the, hey, let's actually apply this, what I call the momentum unit review. I did not attach the answers. What I do have is I've photocopied answer keys. I had 7 of them, and I only got 2 back. I'll have a couple more here. I've also put them online, but I did nuke certain questions. So can you look at the momentum unit review, the one that looks like this? And you can cross out number 7 and number 8. They're cool, but cross them out. And you can cross out number 11, 12, and 14. You'll have to turn the page to do that. And then you can cross out number 5, not the first question 5, but if you turn the page again. Yeah, a car of mass 1,500. Okay. The rest of this is good practice, I think, for your test. You can probably expect 1 more practice quiz. I hope tomorrow, if I get it typed up tonight, I have to create another one. That's just going to have a few more collisions. Hey, we'll look at stuck together or separate. We'll look at bouncing forwards or bouncing. You know, I'll throw a bunch of change in direction types of ones in there as well, if I can get it typed up tonight, and I think I can. Otherwise, I'm going to spend some time going over your work energy test. That'll take about 10 minutes, and then the rest of the class is yours to work. Pause the video.